So, good morning, everyone. So, we are going to discuss in today's class. We are going to discuss with a new concept of module 2. So, module 1, the first chapters, we have gone with a stack. So, second chapter is recursion, and third chapter we will be seeing is queues. Okay, so totally module 2 will have three chapters. So first chapter is stack, so which includes stack applications. So second chapter is recursion, and third chapter is queues. Okay, so now you come with a second chapter. So second chapter is, so you go with a new one, that is recursion. So what is the general meaning of the recursion? So recursion is a part of, okay, so recursion means repeat. So what is the recursion means? Repeat. So what you will be repeating? So what you will be repeating, that we will see. So just you understand what is recursion. So recursion means you are going to have the concept of repeating execution. So repeating the execution of the programs. So repeating the execution of programs. So that one is called as a recursion. So how you are going to repeat the execution of the programs and what are all the things you will be studying. So we will see the topics here. So under recursion, first topic is you have to write the program for to find the factorial of a number using recursion, and find the GCD, find the Fibonacci, and some of the other programs are multiplication, generating prime numbers, next reversing the characters of the string, and finally you go with very important concept. This one is Ackermann's function. So Ackermann's function is very important concept. So all these programs, so what you have given here, so factorial, GCD, Fibonacci, so all these programs are very important from exam point of view. So keep in your mind, all these programs are very important for exam. Understood? So now you get into the detail. So what is a recursion? So recursion is a process which comes into existence when a function calls a copy of itself. So one function is there. You are familiar with a function, right? So you are having two types of function. One is calling function. The other one is called function. So calling function will be inside the main and called function will be outside the main. So called function will call repeatedly. So the function which calls a copy of itself, a function which calls a copy of itself is called as a recursive function. So which part of the program will be executed? The functional part of the program will be executed. If your program is consisting of any function, so then that called function can be repeatedly executed. Understanding what I am telling? So recursion means a function which executes by itself. So very important. So what is the recursion? Any function which executes by itself repeatedly. So keep in your mind this word. So it is repeatedly. So that one we call it as a recursive function. So which part of the program will be executed? The function. If the program will consist of calling function or called function, so that called function will be executed by itself. So calling function will call called function, and called function keeps on executing itself. So repeatedly, that is, then we call it as a recursive function. Okay, so next, any function which calls itself is called recursive function, and such function calls are called recursive calls. So any calling function which calls the recursive functions are called as a recursive calls. For example, you see the syntax here. First is the main we have taken. Inside the main we have taken recurse. So in this recurse, what you are having here, it is called as a calling function. Any function which is inside the main, we call it as calling function. So this one is calling function, and where is the called function. It is outside the main. So here recurse is the called function. So inside this, it is we are having a function name. So that if any function name will contain one of the statement as function only, so then we call it as recurse is the recursive function. So inside the recurse, if this one is not there, so then we don't call recurse as a recursive function. Understanding? So if any called function will have the function name inside that function, so that we call it as a recursive. Understanding? So understanding where you get the recursion, right? So understanding the definition of recursion. Are you understanding the definition of the recursion? So, but you have to keep in your mind, so you are having two types of function, calling function and called function. So any called function which calls itself. So here it is recurse is the function name. So this is function name and it is calling the same function inside. So repeatedly it will be calling. So that one we call it as a recursive function. Okay. So for example, so you can take it this particular concept. So for example, factorial of 5. So how to take the factorial of 5? It is 5 star 4 factorial. So that is here you see there is a function called factorial. I have not gone for any concept. So factorial of 5 will be taken as 5 star, 4 star, 3 star, 2 star, 1. Okay, so that will be taken as 5 star factorial of 4. So what is the formula for to find the factorial? It is n star n minus 1 factorial. So that we take it a function name as factorial of n minus 1. Understood? What is n? It is 5. And what is factorial of 4? So factorial of 4 will be taken as factorial of n minus 1. So this is the concept. Okay. So now you come with examples. So first example we are going to see it. You start from here. First example is factorial. Next is GCD. Next you go with Fibonacci. So first you come for the factorial. Okay. So now you have to find the factorial of a number. Okay. So what is to be done? So you start with a main function. You take the number. So what is this n? N is the number for which factorial to be found. Understanding? So n is the number for which the factorial is to be found. So that one we take it as n is equal to a number for which the factorial is to be found. So next printf, enter the integer greater than or equal to 0. Okay, so it should be greater than or equal to 0. So 0 factorial is 1. 1 factorial is also 1. If you go for 2, it will 2 factorial will be 2 star 1 is equal to 2. So that's why we have to go with enter the integer greater than or equal to 0. So, okay, equal to 0 means it will take 0, it will take 1, it will do 2 also. So, scanf %d ampersand n. So, now you directly go with a function factorial of %d is equal to %d. Okay, so I have taken long data type. So, here %d means a given number, that is integer. But here %ld. So %ld means it is of long data type. So factorial of 3. So factorial of 3 is equal to something. So this %d is for a number what you give, and this %ld is for result what you get. So %d is for n and %ld is for factorial of n. So now what is the you are calling? You are calling a function factorial of n. So here you keep in your mind. So this part, sorry. So this part we call it as calling function. Keep it in mind. So this one we call it as it is the calling function. So where is the calling function? Inside the printf statement. Understanding? So to explain, I am telling you printf. So factorial of n is equal to calling function. Okay. So now you come for the called function. So called function will be outside the main. So calling function, what is the value you are getting? Percent LD. So percent LD will be the factorial of n result. Okay, so LD means long. So take the same thing here. So long int means it is of long data type. What is the result you are getting? It is of long data type. So I will be giving it as long int factorial of int n. So here you see what you have taken. Function name is factorial. So same function name is factorial. Now you are giving here as n and here you are taking it as int n. Okay. So now you come for the condition. If n double equals 0 or n double equals 1. So what should be done? Return 1. So keep in your mind, this one is 1. Okay. So this one is 1. So, okay, else if the n is not 0 or 1, if it is 2, 3 like that. So what is to be found? Return n star factorial of n minus 1. So what you will write? N star. So suppose it is 2. What you will do? 2 star 1 factorial. So 2 star 1 factorial means you are taking it as factorial of n minus 1. So factorial of n minus 1. Understood? So here you see this function name factorial is again calling this particular function name factorial. So that's why we tell it as recursive function. So here factorial will be taken as a recursive function. Understood? So now you see first if you are given the value as 2. So it will return n star fact of 2 minus 1. So n star fact of 2 minus 1 will get you 2 star fact of 1. So fact of 1 will again go for the execution. Now n becomes 1. When n becomes 1, return 1. So it will be 2 star fact of 1 is 1. So 2 star 1 is equal to 2. Understood? So this is up to the program of factorial. So have you got this recursion factorial using recursion? Okay, then kindly answer where we use recursion, inside calling function or inside called function? Where we use recursion, inside calling function or called function? So I've given the example of factorial of int n. Okay. So where is the recursive function here? So which line marks the recursive function? There are two lines. One is if, the other one is else. So where is the recursive function? In if line or in else line? Else line. Okay. So are you understanding right? You are right. It's in the else line only. So now you come for the next particular program. So that is GCD and LCM using recursion. So what is to be done for GCD and LCM, that we will see in this particular thing. Okay, so what you do here, so using recursion. So now you see, if you want to get the GCD or LCM, what is to be done? So first we start with a main program. So next GCD we take it as HCF and LCM. So X comma Y comma one parameter, one output parameter for that is GCD, that is HCF. The other parameter is for LCM. So GCD will be the function which takes two numbers. So whereas LCM is also will also go with the two numbers. So printf enter the two numbers. Here we are scanning. So next you call the function. So now you are calling the function HCF is equal to GCD of X comma Y. So it is the calling function. So this one we consider it as calling function because it is inside the main. Okay. So now if you want to get the LCM, what is the statement you will be giving? It is X star Y divided by HCF. So HCF, you have to, in order to calculate the HCF, we have taken a function called GCD of X comma Y. So GCD of X comma Y. So similarly, if you want the LCM, what you will get? It will be X star Y by HCF. So this is the formula. So here you know calling function. This is the only calling function we are taking. So once you get the HCF, you can easily calculate the LCM. So LCM is equal to X star Y divided by HCF. So once you calculate this one, so which is the function we are taking inside the main? It is only GCD of X comma Y. So once you get these two values, you are printing. GCD is equal to %D, LCM is equal to %D, HCF comma LCM. Understood? So now you come for the function, how to calculate the GCD. So int GCD of X comma Y. So that means dividend, one is the numerator, the other one is the denominator. So numerator we call it as dividend and denominator we call it as divider. So now you come for remainder is equal to, you have to calculate remainder. So division will give you two things. One is the quotient, the other one is the remainder. If you want the quotient, you have the symbol slash. So slash will give you quotient, whereas percent will give you remainder. Okay. So that is int remainder is equal to dividend mod divider. So go for the remainder. If remainder is 0, if you get the remainder as 0, return divider. Else if you get the remainder as any other like 1, 2, 3, again you go with GCD of divider comma remainder. So keep in your mind what you are doing. So when you have, so first you will have dividend and divider. So you calculate the remainder using dividend, that is numerator, modded with divider. If you get the remainder as 0, then GCD is divider. If you get the remainder as 1, 2, 3, any other number, then again you call the function GCD of divider comma remainder. So this is the concept. Okay. So first you will go with dividend divider. If remainder is not 0, you go with divider and remainder. So keep on doing. Okay. So this will be keep on doing the entire execution. Understand? So now for that we see, so we are having int GCD. So int GCD of int dividend comma divider. So remainder is 0. So it will return divider. If remainder is not 0, it will return GCD of divider comma remainder. Understood? So this is the program. Once you calculate, so where is the recursive function? Here you see, this is the called function. Inside the called function, you are calling GCD of divider comma remainder. So this here we are having the recursive function. So this one will call recursive call. So this is the recursive call you are having. Understanding? So for that one, you will take the numbers. Two numbers we have taken, 12 and 75. So what is the GCD? You will get it as 3 that you have to work it on. So first you have remainder 12 with 75. So remainder will be, you can't divide 12 with 75. So remainder will be 12 itself. So when you have the remainder with 12, now you have 75 comma 12. So 75 comma 12, and you have to calculate the GCD. So until you get the remainder as 0. If you get remainder as 0, then that divider will be the answer. Understood? So this is the program of GCD and LCM. So what the program? So have you got this particular GCD and LCM program? Kindly reply me. So now you come for the very important programs are Factorial. Second one is GCD LCM, and now you come with the next part. Sorry. So first I will finish with the Fibonacci series. So anyone know about Fibonacci series? So can tell how to generate Fibonacci? Can anyone tell how to generate the Fibonacci series? You have this program in your first year, right? CCP lab. Yes, respond here. How you generate the Fibonacci series? By adding previous two numbers. Okay. So now you come for. So fib of 3 is equal to fib of 1 plus fib of 2. Okay. So now you go with the concept. So Fibonacci series means you will be having two numbers. One is 0, the other one is 1. Okay. So defaultly you will be having two One is 0, the other one is 1. Next you go with a, next you will be keep on adding the numbers. So 0 plus 1 will get you 1, 1 plus 2 will get you 3, 2 plus 3, 5, 5 plus 8, 2 plus 3, 5, 3 plus 5, 8, like that. Okay. So first you want to generate. How you are going to generate? So first if you give 0, so 0 means, so fib of 0 is 0 only. So fib of 1 is 1 only. So when you have two numbers, now you generate the fib of 2. So fib of 2 is equal to fib of 0 plus fib of 1. So keep in your mind how you generate the Fibonacci series. So first if you have fib of 0, so fib of 0 is equal to 0 only. Next you go with fib of 1, fib of 1 is equal to 1 only. Then you once you get all these two numbers, so next you give fib of 2. So fib of 2 is equal to fib 0 plus fib 1. So what that is equal to, what is fib of 0? It will be 0. Next you have fib of 1, that is 1, that is equal to 1. So first number is 0, second number is 1. So keep on adding hereafter. So similarly you will be having fib of 3. So you have gone with a fib of 2. So fib of 3 is equal to, so what you can write? It is fib of 1 plus fib of 2. So fib of, what is fib of 1? It is 1. And fib of 2, it is 1. So 1 plus 1 is equal to 2. So first number is 0, second number is 1, third number is 1, fourth number is 2. So next you add 1 and 2, you will get 3. Next you add 2 and 3, you will get 5. So this is the concept. Okay, so first you take it n and x. So x for loop variable, n is the how many numbers you want, so how many series of numbers you want. So n is for number, x is for loop. Okay, so print, enter the term for Fibonacci series. So you will be taking scanf ampersand n. Okay, now you call x is equal to 0. You start from where? You are starting from 0 and you are ending with nth variable, keep on incrementing. So now I call Fibo of x. So Fibo of x, it is called as a calling function. Okay, so Fibo of x is the calling function and it will go there. So now you see, here we have taken Fibo of int n. Okay, so Fibo of int n. So Fibo of int n with first, if you have n value is 0, so that means if you put n value of 0, fib of 0, so it will return what? It will return 0. So that's why we take return 0 here. So if n double equals 1, so that means you are given 1 here, what should be the value? It will be 1 only. So similarly, but if you go for next numbers, so you won't perform any addition in fib of 0 and fib of 1, but you will perform addition where? When you go with a fib of 2. So if it is not 0 or 1, so then you have to go with, so this part will come for what? When you have n value is equal to 2, 3, 4, dot, dot, dot. So for n value 2, 3, 4, you will be using this particular statement. So this particular statement is, so fib of, if you are finding 2, so it will be fib of n minus 1 plus fib of n minus 2. So that one we will be taking it as, so fib of n minus 1 plus fib of n minus 2. So this is the, so here we call fib of n minus 1 and fib of n minus 2. So we call it as recursive. So it one is called as a recursive call. Understanding? So this one is a program on using recursive function. Understood? Got it? So that are the three important programs what we are going with this series. So, so now you come for the next program. So that three are important. First one is Factorial, second one is GCD and LCM, and third one we go with Fibonacci. So after these three, we go with some other programs. So some other programs are multiplication by recursion. So multiplication is what type of operations? Can you tell? So multiplication, so it will take two operands because it is a binary operator. So two integers we are reading. So printf %d into %d is equal to %d. So this one is A, this one is B, and this one will go with multiply of A comma B. So how you multiply? So this is the calling function. Here you go for the called function. If x and y are 0, so you have to go with two cases. If both the inputs are 0 and x is less than y and x is greater than y. So if x and y are 0, you will be returning 0. Similarly, if x is less than y, you have to go with multiply of y comma x. So this is multiplication. So here function name is multiply. Here you are calling recursive function, and here also you are calling recursive function. If x is less than y, return, exchange the values. So here you do exchange the values. Okay, so x is less than y, return multiply of y comma x. So similarly, that means if it is not 0 and if it is not, x is not less than y, so this one will come for, so if x is, this one is for x greater than y. So I am giving you, so this is for x greater than y. What you will do? X plus multiply of x comma y minus 1. So this is the formula what you are going to take it for multiplication. If x and y are 0, return 0. If x less than y, what you will do? Exchange the values using mul of y comma x. So next, so if x less than y, return mul of y comma x. So if x is greater than y, okay, so what you will do? You will return x plus multiply of y comma x comma y minus 1. So this here you are using the recursive call once, and here you are calling recursive call twice. So two recursive calls we are making here. So in every program we go with a one call, but here you are going with a two calls. Okay, so two numbers what you take, 13 and 5, so it will get you 65. So this is the program used for multiplication by recursion. Understood all programs? Okay, so I hope you have got understood all the programs of today's class. Okay, so those who have not given your attendance, kindly use this link to fill your attendance. So remaining everything we shall see in the next class. So thank you all.